Magnitudes. Now, magnitudes is how we measure the brightness of a star or other celestial objects. We do this by using a backward logarithmic scale, where negative numbers indicate brighter objects and positive numbers indicate fainter objects. Relating it back to magnitudes, fainter objects have a larger magnitude, whereas brighter objects have smaller magnitudes. Now, I'm going to put here to remember that the apparent magnitude tells us how bright the celestial object appears from Earth at visible wavelengths. Which does bring me to my next point. There's two types of magnitudes you should know. One, apparent magnitude, represented by lowercase m subscript v. This magnitude tells us how bright the celestial objects appear from Earth at visible wavelengths. And two, absolute magnitude, represented by capital M and the subscript v. This magnitude tells us how bright the celestial objects are at 10 parsecs. With knowing the magnitudes of celestial objects, we can find ratios of their luminosities and fluxes using these following equations. We can also measure the distance to celestial objects using the distance modulus. The distance modulus uses the difference of apparent and absolute magnitudes of celestial objects to calculate the distance to that object from Earth. This is shown by the following equations. Both these equations are equivalent to each other, so you can use either one. The distance on 10 parsecs term compares the distance to the celestial object for if it were located at 10 parsecs. We also use this reference point to show absolute magnitude of celestial objects, as also shown in this equation. The first equation does not show this. One could say that it's a simplified version of the bottom equation. By using log laws and some rearranging, you can get to the bottom equation to the top equation. Let me know in the comments below if you want me to show this rearranging. That also goes for the luminosity and flux ratios as well. Hopefully this video helped, and I will see you in the next one.